overall design of the agent. Now we need a driver function or the driver code for calling this agent, giving it the environment. It will simply do all the cleaning stuff, and then it will stop. So for that, for Python, we don't need to write anything as class or method or anything. Okay, we can simply write the whatever we want to write, and then it will simply execute it. So directly we have already defined the environment. So just make it, I just cut it from here and then I'll paste it for a better
In the
understanding.
loop, where are we looping to? Because in the move, we just incremented a row or a column.
Yes.
Where are we? In as part of act, we said move, and we came to move, and we incremented to the
Yes.
next one. But
Yes.
then the control has to go back to perceive, and
So the
then
control is in our hand. It is not the agent. It is not in the agent's hand, right? So that is the driver code I'm going to write. The agent
okay,
only
okay,
have these options. It can perceive, it can perform the action, and it can decide the next move.
okay.
That's it. Now, the control is in our hand when it will move or when. So we will give it the. We will every time we'll give the environment, and it will simply based on that it will decide. Okay. Once I write the driver code, you'll understand.
So you moved the environment is equal to np dot array from top to the further down, is it?
For better understanding, even
Okay,
if you
okay,
write it over there, that is not a problem.
okay, okay.
Okay. Now, just let me just print the initial environment. So this is the initial environment. Okay. I'll simply write the initial environment as environment. Okay. Now I'll create an agent. So this is simply, I'm just calling a object of the function that I have already written over here, which is the agent function. And sorry, which is being stored inside this agent. Okay. Now I'm just uh, calling this class, and as the constructor is having this environment variable, we need to pass the environment while I'm calling the constructor, or I'm create instantiating the class. So this is the environment. So you can also write in this way: environment is equals to environment. So this is the variable name which is being used inside this class definition, and this environment is that variable which we have used over here. Okay, this one. So if you know that this is the first one, you can simply remove it and you can simply pass, because we only have one variable over here which we need to pass. So for that, I'm simply writing environment. Okay. Now I'm just running an infinity loop while true. It will simply check all the cells of the environment. Okay. Now, first I put a condition, like if all the cells are clean, we want the agent to stop. Okay. So if np dot all, this is the function which will check all the cells. Okay. And we are going to pass the environment matrix inside it. And we want all the cells to be clean. Okay, so we will simply check by this function that all the cells inside this matrix is clean or not. All right. If any one of the cell is false, it will simply throw a false, return a false. Else it will return a true. And once it is true, we want the agent to stop. Now we will simply print one line over here. All locations are clean. Stopping. Sorry. Okay. Now, once it is not clean, then we need to act the agent. We need actions to be taken by the agent. Now we'll simply call the act function from the agent. So if it is a standalone function, then you can simply call it like in this way. Let's say in this way. But we have not defined this function as a standalone one. It is an attribute of the simple reflex agent class. So for that, we need to use this object which is being created over here. So we'll simply calling it as agent.act. Okay. Now, once the action is being taken, I need to print the environment state, current environment state. Okay, let me just write agent dot environment. Okay, now let me just go back to here. So once I call this act function from here outside, I have the remote controller with me. I'm calling this act function, which is the take an action. I'm just asking the agent to take an action. What it will do, it will simply perceive the environment first. It will simply perceive the environment. It will check that if the location is dirty or not. If dirty, it will clean it, change the current state, current cell state to clean. If it is clean, then it will simply take a move. Okay, how it will move, that rules have already been written over here. All right, so we need to only call this act function.
We
So
don't have to pass any parameters or
no, actually, why not? Because this is the self, this is inbuilt over here. Okay, we don't need to write it as self. This is only for understanding inside the class. But
okay.
once I have something like a b c, then we need to pass it, else it will throw an error. But as of now, we don't need to pass any other parameters over here
Okay.
because it is only using its own attributes, right? Once we have to provide something from outside, then we need to
Okay.
define. Yeah. All right. Now, this is not necessary, this time one, but once I run this code, it will simply execute it. Okay.
Sorry, but did you need to break it after once it got cleaned in the while loop
Yes,
after
you
if?
are right. Yes, you are absolutely right. Absolutely right. Yes. Thanks for pointing out. So yeah, it's over. Now I just need to run it. So it is already executed. Okay. But for just checking what are the steps is being taken by the agent, I'm just giving it as time.sleep for 5 seconds. So after every step, after every iteration, it will just simply take a break of 5 seconds so that we can simply visualize the output. Okay, let me just execute it. So here is the button execute cell, or you can simply go inside the cell and you can press Control Enter. It will execute it. Anyway, you can do it. Now see, the initial environment is this one. Sorry, there is a typo. I'll check it. Now first it will go to the 0, 0 location. If it's dirty, it's cleaning. Then 0, 0 is clean, then moving. Okay, so first it is checking for the dirty cell. It is cleaning, then it is checking again. If it is clean, then moving. Then the next is clean, it is moving. Then also it will go to 0, 2. It's cleaning, then 0, 2 is clean, then moving. 1, 0 is already clean, moving. Then 1, 1, it is dirty, it is cleaning. So as you can see that it was dirty, then it has been changed to clean. Okay. Now it is again checking. 1, 1 is clean, then it is moving. Then it is going to 1, 2.
So,
Okay.
Professor, instead of writing while true,
Yes.
you may not write a location and means like we are doing one by one. So at the end, location is empty, right?
So in a real life scenario, let's say the agentic simulations are being performed in autonomous vehicles or any other machines which are simply perceiving the environment and taking their own decisions. So in that case, we don't have access to how many uh, conditions are there in in the environment. Let's say,
Sure.
sorry. For example, we have this environment over here predefined that I know that there are 9 cells. So you are saying like I can just run it for loop, right? For all
No,
the cells.
not run it for loop. Location is NA means like if location all the from the top we completed everything, all
Hmm.
the locations are complete,
Hmm.
then we can exit also, right? Just
So that is what the agent is doing. So agent is perceiving that how many locations are left. So
okay.
it knows that at current location, what is my row and column index.
Mm-hmm.
Once the row and column index is over, then it will simply move out.
Okay.
Okay.
Got it.
But essentially in real life scenario, we don't have any it's a never ending environment. There are a lot of options that can happen. There are a lot of other choices, lot of other actions which the agent can take. And also we don't have control over the environment size. So for this specific toy example, we have the control. That's why we can actually see that, okay, there are 9 cells and we can stop now. But actually the agent has no idea. So it has to go to each and every cell and check that whatever is the condition, and based on that, it will take action. That will be very clear in the next example, uh, which is the utility based agent, because here we are simply following a brute force approach, where we are taking all the rows and all the columns, like from starting from 00 till 22, all the rows and all the columns, all the cells we are visiting in a brute force manner. But for the utility based agent, it will calculate an utility function, and based on the value, it will go to some different cells. And it may also happen that the agent is unable to finish all the cells if you have lower number of iterations. Here I have given it as a brute force approach, so I am sure that it will visit all the cells. But in a utility based agent, if I just give a smaller number of iterations, then it may not visit all the cells. That is completely dependent on how you write the utility function. Okay, so it is very important that you should write a proper utility function or a reward function which the agent is going to learn. So I
Just to
hope
find
that
out,
Sir, I have
yes,
can you please move to move function?
yes.
In else if why that is 0 is there, that should be column, right?
That should not be column, because the column index is 0. Because once I am here, let's say where is the environment, once I'm here, so this is indexed as 0 2, right? Now I
Correct.
cannot skip to the next column, so I need to move back to the second row, first column. So that will be indexed as row plus 1, whatever row I am in, that will be plus 1, and then first column, that means 0.
Okay.
Yes, you just simply play with the code. I hope you can follow me whatever I have done. Else you can go through the recorded lecture, no problem. You can simply play with the code and change these
uh,
functions and how the
kind
environment
of
is being perceived and all. Yes,
sir, I have one doubt.
yes, yes.
Is it a AI agent, sir?
No, it's a simple reflex agent. It's not an AI agent.
Basically, a simple Python code of if and else condition that we have applied.
Exactly. That is what I already discussed, that a simple reflex agent is supposed to follow the if else statements. And
Okay.
based on that only, it will act. But
Okay, sir.
uh,
Thank you. Yeah.
yes, once we discuss about the utility based agent, you will understand that how a reward function works.
Ayanaba, just one thing.
Yes,
Can you go up the code? Yeah. So once it cleans 00,
yes,
after that it again act. It will again act at the call the act function, right?
yes,
So it
yes,
will again check whether it is dirty or not.
yes, yes,
So we are basically checking one location twice.
yes, 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 exactly.
Okay. So that
One
that that
action at a time. So
yeah, that's a
that's what I
drawback,
said.
right?
That's a drawback, exactly, because this is a very simple agent. So
Hmm.
there are a lot of drawbacks. Even if you don't know the environment, like I know that there are 9 cells, so
Hmm.
I'm just executing it for 9 times, or maybe the for loop is being or the while loop is being
Hmm.
executed for 9 times.
Hmm.
But in real life, these kind of agents cannot work, because I cannot check all the cells in our art. Let's say I divide the earth into multiple, like millions of cells, and I just run an agent, which is just a simple reflex agent, and it will clean. Okay, so that is not possible for the agent to clean all, like in a brute force manner. I need to optimize the cost function or the move function in such a way that it will take an informed choice. That's what I said, informed choice, during when I was explaining the theory.
Hmm. Right. Right.
Yes.
Thank you.
So there are a lot of drawbacks. This is not at all an ideal agent, but this is a very simple one. Okay.
I do have a question, sorry, in
Yes, yes,
reflex agent. Actually, two questions. So, firstly, can you go to the move function?
yes,
Yeah. So, in this, we are determining the shape of environment every time, right? Now,
yes.
shape of environment would not be changing every time. So, it could very well
So
reside in the.
when I was
Mhm.
explaining, I already mentioned that the environment is not supposed to be, given at the very beginning. What I mean to say is, like, the environment should not be a part of the agent. Okay, But for the execution purpose, I have given it as an attribute, but every time you should supply the environment to the agent. Okay. That's why every the environment is used, I'm simply changing the environment. Okay. So there also the environment is being changed. And this is essentially when you are checking the environment, you should know that what is the shape of the environment, and then according to that, you can take a choice. Okay. So that's why I said that you can actually put them as an attribute, but this is not theoretically ideal for an simple reflex agent, because this agent must not have idea of the environment.
Another question is the moving of agent from one location to another location is just done sequentially for simplicity purpose and
Exactly.
not the
Yeah.
neighboring.
In a brute
Okay.
force manner, all the cells will be visited.
No, actually my question is they're not visiting only the neighboring cells. It's visiting
Neighboring cell is the
sequentially.
concept for utility-based agent. There is a
Okay.
second one.
Okay.
In this case, in brute force manner, all the cells will be visited without being
Got it.
informed that which one is
Mhm.
dirty, which one is clean. Because on the clean cell also it is moving. But for a utility-based agent, it is not supposed to visit a clean cell because it will have some information about it. Okay.
Thank you.
I think it's already
Just one question. In this agent, we are just describing the like location of the agent, and related to like whether it is clean or it is dirty. We should have some different type of
different type of.
mechanism. Like currently, we don't know what is the degree of cleanness or dirtiness. That is like something different thing, right? Not including that.
Your question is not clear to me.
My question like there will be some degree of cleanness.
Those who are not speaking, just please put yourself on mute. I'm not able to hear. Yes, Akash, go ahead.
My question is like in this agent, we are just describing the location of the agent, like whether it is clean or dirty.
Yes,
But
yes.
related to whether how much it is clean or dirtiness, that this should be determined from some another agent or like
That
mechanism,
is going
right?
to be a complex environment, because once
Okay.
you are getting the information that how much it is clean, how much it is dirty, so that is a part of a complex environment where you have the when you have some sort of quantification of how much dirty is the room, how much clean is the room. But here I am simply taking a binary situation where the room is clean or dirty.
Okay. Got
Got
it.
it. So, sir, I just want to know, Dr. Devasys, sir, if you are there. So, do we have time for discussing the utility-based agent, or
No.
sir, are you there? Think.
We have another lecture, I think.
Yeah.
I think we have another lecture at 4:30, and since 8 o'clock we have been doing this, so I think we need a break.
Okay, okay, great. Then I'll talk to the instructor, Dr. Devasys Das. I'll talk to him, and